in exercise 3.4.3 we have two distributions. We have S1 and we have S2. And S1 is compound Poisson distributed with intensity parameter lambda 1 equal to 4 and a severity distribution P1 in J is equal to 1 over 4 J 0, 1, 2 or 3. So it has equal probability of getting 0, 1, 2 or 3. The other distribution is S2. It's also a compound Poisson distribution, but now the intensity parameter is lambda 2 and that one is equal to 2. And the distribution P2J is equal to 1 over 2 if J is equal to 2 or 4. So the claims in the S2 distribution are either equal to 2 or equal to 4 with equal probability. And of course we assume that S1 and S2 are independent, because then we can use theorem 3.4.1 that tells us that the random variable S, which is S1 plus S2, is also compound Poisson distributed, so it comes from the same class as the S1 and S2 distributions, but now the intensity parameter lambda is equal to lambda 1 plus lambda 2, which in our case is equal to 6, and the severity distribution, so the Px distribution, it's lambda 1 divided by lambda, and now we know that lambda is equal to 6, times the P1 distribution plus lambda 2 divided by lambda P2 in x. And of course, because lambda 1 is equal to 4 and lambda is equal to 6, this one here, it's 4 divided by 6, and lambda 2 divided by lambda, it's 2 divided by 6. So then, for example, you can calculate P0, because then in this formula I put x equal to 0, it's 4 over 6 times P1 in 0 plus 2 over 6 P2 in 0. The P2 distribution only takes values in 2 and 4, so this is equal to 0. P1 in 0 is equal to 1 over 4, so here you find 1 over 6. If you do the same for P1, we find 4 over 6 times P1 in 1 plus 2 over 6 P2 in 1. Again, this one is 0. P1 in 1 is equal to 1 over 4. So here you find 1 over 6. P2, or P in the value 2, again 4 over 6 times P1 in 2 plus 2 over 6 P2 in 2. So now this probability here is equal to 1 over 2, and this probability, it's still 1 over 4. So here you find 1 over 6 plus again 1 over 6, which is 2 over 6. Finally, P3 is equal to again 4 over 6 P1 in 3. Again, P2 in 3 is equal to 0, so here you automatically find 0, and you find that this is equal to 1 over 6. The last probability is P4. I can calculate P4 as 1 minus all the other probabilities. It's P0 plus P1 plus P2 plus P3. And this here is equal to 5 over 6, so here you find 1 over 6. And then we have the distribution of S, because S is now compound Poisson distributed, intensity parameter is equal to 6, and you have the distribution of the claim sizes. So the probability function Px is given. We have calculated this function for all the values that we can have for our severity distribution.